Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and this is a fantastic day to do analytical geometry. Now, you will see that I'm going to divide this into two parts. This first question that we're doing from the Department of Education, specifically the Gauteng Department of Education, has got two questions. The first one is a lot more of a straightforward question, and that's gonna be our part one. And then we're going to dive into one that is a bit more on the difficult side, a bit more challenging, and that is going to be our part two. So as part of part one, I want you to take in this information. They're asking you A, B, C, and D are the vertices of a trapezium. Is the midpoint, and the angle of inclination of the straight line BC is theta, as shown below. This is the questions. Calculate the coordinates of E, etc. I'm going to ask you to hit the pause button on the video and try these ones yourself until you are ready, and then you continue on with this video where I'm going to go and show you how I would answer these questions. So when we specifically look at this and we just analyze this question, there's a bunch of very important things that you always need to think about. So first of all, they tell me it is the vertices of a trapezium. So in other words, those sides are parallel. Now, when it comes to this, even though it's not used much, I want you to then remember that the gradient of AD is going to be equal to the gradient of BC. Okay, so those two gradients are the same. So if I could by any chance get one of their gradients, they're going to be the same. Now, there are many other interesting things that I can use because it is a trapezium. So I could maybe go with alternate angles. I could go with anything in the F, the U, or the N. But I'm not going to dive into that much in this sum. So let's quickly look at the first question. It says there, calculate the gradient or the coordinates of E. Now, E is the midpoint of BC. So in other words, I'm going to start by writing out the formula for midpoints. Okay? But please be careful that there must be a semicolon in between, not a comma. So I'm taking those two sets of coordinates and I'm doing the x part, so 3 plus 12 over 2. And also I'm doing the same with the y parts, 0 plus 3 over 2, which means E's coordinates is 7,5 semicolon 1,5. Now you can go and put this in as 15 over 2 and 3 over 2. That's 100%. I don't mind that. I actually prefer using fractions. But let's quickly look at 3.2. It says they determine the gradient of the line BC. Fortunately, looking at the sketch, for B and C, I was actually given the coordinates 3 semicolon naught and 12 comma naught. So when going forward to this, let me jump there again. I'm going to go and write out my formula. Now you will see that I always write out my formula. The reason why I always write out my formula, ladies and gents, is the more I write it out, the better I remember it. Silly little thing. But the more I write it out, the better I'm going to remember it. So when looking at this further, the gradient of BC is 3 minus 0 over 12 minus 3. As simple and as easy as that. So the gradient between B and C is 1/3 of units. Please now understand that is automatically now the gradient of both BC and AD. Okay, remember that. Keep it in mind for future reference. So when we look at the next question, calculate the magnitude of theta. So looking at the sketch, I'm just going to jump back to the sketch. Which lines are being touched by theta? If I look at that, the lines being touched by theta is, take a look at it, BC. Therefore, I need the gradient of BC to get theta. There's a nice little trick I want you to remember. That the moment that theta touches a line, that is the gradient I'm going to need. Fortunately for us, the gradient we just calculated as being 1/3. So to get theta, I'm simply going to say arctan of 1/3, which is 18,43. Now you might not be familiar with the terminology of arctan, but that on your calculator is just calculated as shift tan, or tan to the -1. Okay, but formally in maths we love to use the word arctan. That's the right terminology. Now let's quickly look at question 3.4. Question 3.4, it says there, prove that AD is perpendicular to AB. So my question that I want to ask you is, how do we do it? We do perpendicularity by saying the gradient of AD times by the gradient of AB is -1. Grade 11s, that's what we need to prove. It's not I can assume it. I can't say it is equal to -1. I have to prove it. So how do I prove it? Well, I know that the gradient of AD is the same as the gradient of BC. That is 1/3. But now I need to calculate the gradient of AB. So I'm going to again use my formula of y2 minus y1 over x2 minus x1, and I get a gradient of -3. I'm looking on the left-hand side of what I want to prove, and I'm saying -3, that is the gradient of AB. If I multiply that by the gradient of AD, which is 1/3, I get -1. That is exactly what I wanted to prove. And hence, AB is perpendicular to AD. I want you to get into my mind the way that I'm thinking. The way that I'm thinking is, what do I need to prove? Then I know what I need to do to get there in the end. I hope you get this, ladies and gents. This is almost more important than answering the question. It's how we problem solve. Now we get to a very interesting question. And for those of you that struggle with English or with analyzing a question, it really helps to draw what they are telling you here. So they say a straight line passes through the vertex of A. So in other words, a line goes through A, but doesn't pass through any sides of the trapezium. So it's kind of like a tangent to that point, if I can, use that terminology very loosely. Okay? In other words, it passes through A, but nothing else on no other line. And this line, so that is the only way that a line is not going to pass through any of the other lines, makes a gradient of 45 degrees. Now the question is to be asked. Determine the equation of this line. So for me to get the equation of this line, I know that I need to get that 18.43. Now, where on earth does that 18.43 come from? And why do I need it? Well, remember, the 18.43 was the inclination angle of BC. Now, for me to get the inclination angle of AD, I'm always going to now draw a line that's parallel to my x-axis. And this inclination is the same as that inclination. That's where the 18.43 comes from. But now, why do I do this? This is the big question. And the question is actually determine the equation of a straight line. So I need m. For me to get m, I've got four options. Either do the straight line formula or the straight gradient formula, y2 minus y1 over x2 minus x1, or parallel lines, or perpendicular lines, or inclination angle. Those are my four options I have at this moment. So the question is, do I have the inclination of that line? Well, I do. It's that 18.43 plus the 45 because the inclination is that whole angle there. So the gradient is equal to 2, which means I have the gradient. All that I need now is another set of coordinates. Well, do I have another set of coordinates? Do I have a set of coordinates on that line? I do. I have the set of coordinates 1, 6. That is A's coordinates. So I'm going to substitute that in, and I'm calculating C to be equal to 4, which means my equation is y equal to 2x plus 4. And there, ladies and gentlemen, you have it. So it all comes from analyzing what questions I have, looking at where I'm going, and then saying, okay, how do I get there with what I have in my hands? I hope that you enjoyed this video, ladies and gents, and please tune in for part 2 that's coming up next, which is a bit more of a tricky question. But this is Mr. VG signing out. Have a beautiful and amazing rest of your day or evening or morning. Keep well. Cheers.